All right, let's do the four-step process in doing a significance test for proportions. This lesson's also going to show you a different type of alternative than the ones we've seen before. So as always, the four steps are state, plan, do, and conclude. So some minor differences between the four steps for a confidence interval and four steps for a significance test. You still want to be sure you are always stating your parameter. You're defining your variables. You are going to tell what statistic you're using. What statistic you get from the sample. You need to make sure you write your null and your alternative hypothesis, and you need to set your alpha level. Remember, your alpha level is your significance level, and the most common one used is 0.05. If you're asked to choose your own or they don't give you an alpha level, you stick with 0.05 because that's the 5% cutoff that we're used to working with. We want to always name our test. So far we only have one test, and that is a one sample test for proportions, and we want to check our conditions. In your do step, want to make sure that you put your general specific formulas, your picture, that would be your normal curve with the shaded region of the probability you're looking for, the work, and then of course your p-value. And then your conclusion, we do or do not have evidence against the null. And remember, your conclusion has to have three parts. So what we're looking at today is something called a two-sided test. So when we're doing the four steps, we're going to go over the four steps, and then we're going to also talk about what a two-sided test is. And that is when our alternative is going to have two sides, which means when we shade our picture, we're going to be looking at two shaded regions instead of one. All right, so let's do a problem. According to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A news report claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees find that 68 answer yes when asked, does work stress have a negative impact on your personal life? Do these data provide convincing evidence at the alpha equals 0.10 significance level that the proportion of all employees in this chain who would say yes differs from 0.75 from the news report? All right, so your parameter, P, is going to be the true proportion. You always want to define your variables because you're going to use P in your hypothesis, and the reader needs to know what P stands for. The true proportion of employees who say yes. So your statistic is going to be P hat. So that's, remember what we got from the sample, 68 over 100. So 0.68. All right, so your hypothesis. Our null hypothesis, remember that we always assume is true, is the true proportion is the 0.75, which is the claim from the news report. The alternative says we want to see if it's different from 0.75. So if you'll notice, your statistic of 0.68 is kind of far away from 0.75. Now, you could have said, the problem could have said, okay, so since your statistic 0.68 was less than 0.75, we could have had an alternative that was less than 0.75. But because the way the problem's worded, it uses the word differs, we want to have our proportion not be equal to 0.75. This is how you know you have a two-sided test. So if you use the words less than or greater than, that's going to be a one-sided test. If it says differs, you're going to use the not equal to, and that's going to be a two-sided test. It told you your alpha level is 0.10. All right, so the name of the procedure is a one sample Z test for proportions. And our conditions. All right, so random. Did we have a random sample? Yes, in the reading it says a random sample. So this was stated in the problem. So check. Independence. Remember, that's your 10% condition. Is 100 less than or equal to 1/10 of all employees? I would say that's safe to assume since it uses managers of a large restaurant chain. So I think it's safe to assume there's more than 1,000 employees in this large restaurant chain. And then we need to check our normal condition. So we do N times P, or P hat. So 100 times 0.68 is 68. And then 100. Oh my gosh, I did it again. Y'all, it's not 0.68. It's always your null hypothesis value. So it should be 0.75, 0.25. I did that in the last video. So hopefully y'all learned from my mistakes. So N times P, not P hat. These are both greater than or equal to 10. So your normal condition has been satisfied. Now, one other reminder is if you are checking your conditions and you either can't verify that a condition has been met or it's just flat out violated, I want you on your AP exam to keep doing the problem. They're not going to ask you to do a problem that they don't want to see that you know the steps. But make sure in your conclusion you say something, well, hey, we might not be too confident of these answers. I actually maybe not use the word confident. Hey, we might not be, these answers, my answer may not be very reliable since the blah, blah, blah condition has not been met. All right, so your general formula, and this is your test statistic. And remember, this formula is on your formula sheet. It's your statistic minus your parameter. So remember, that always comes from your null hypothesis over your standard deviation. So more specifically, Z equals the statistic minus the null hypothesis divided by the standard deviation. So that's going to be the square root of P 0.75, yep, times 0.25 divided by 100. And so your Z score is negative 1.63. So we're going to draw our picture. Negative 1.63 and 1.63. Now remember, this is two-sided. So it said that we wanted to find, is this restaurant chain, is their employees proportion different than the national claim of 0.75? So we have to look greater than or less than. So we have to make sure we're doing both sides. So anytime you're doing a p-value for a two-sided test statistic, when you put your normal CDF, negative infinity to negative 1.6301, you're going to get 0.0516. But that is just right here, 0.0516. So this side is also 0.0516. Remember, symmetric curve. So your p-value is 2 times 0.0516, which is 0.1032. Now, I got kind of mixed up from my labels. So my work was actually, let's change the color here. So the work was actually right there. Your test statistic is Z equals negative 1.63. This is your p-value. So of course, then your picture's right here. So I got a little mixed up with the labeling, but that's because I write too big. All right, so then we need to conclude. So remember, your conclusion has to have 3 parts. We need to link the p-value to your alpha level. Since your p-value, which is 0.1032, is greater than our alpha, which is 0.10, we fail to reject the null hypothesis. We have convincing evidence this restaurant, I couldn't remember what we were doing. This restaurant employees proportion who would say yes is different than the 0.75 that was claimed in the news report. So we have convincing evidence that this restaurant, and if you always get kind of messed up with your structure of your sentences, you can go right here. Do these data provide convincing evidence, blah, 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 that the proportion of all employees in this chain who would say yes? All right, so we have convincing evidence that this restaurant's proportion who say yes is different from 0.75. So a 90% confidence interval for the restaurant worker data was also created and found to be, you can see it right there. Explain how the confidence interval is consistent with, but gives more information than the test. So if you're looking at that interval, 0.75 is actually inside of that interval. So that means 0.75 is a plausible value for the true proportion of employees who say yes. So that means we can't reject the null. It could very well be true. So the null of 0.75 is included in this interval, so it's plausible. Therefore, the confidence interval supports our conclusion to fail to reject the null. We are given more information with a confidence interval since we now have a range of plausible values that could be the true proportion. So sometimes a confidence interval can be used to answer a test of significance. You can only use a confidence interval to draw a conclusion about a null and alternative hypothesis only if the alternative is two-sided. Notice the connection between the significance level and the confidence level. So now let's talk about why. So if I draw my horribly symmetric normal distribution curve, and if I do 0.90, remember how we have to write 90% will fall between the two values when we're doing a confidence interval? Doesn't that leave 10% down here in the tails of our picture? So that's the connection between the significance level and the confidence level. So if you have an alpha level of 0.10, that corresponds to a two-sided test where the alpha level is 0.10 corresponds to a 90% confidence interval. So if you had an alpha level of 0.05, then that would correspond to a 95% confidence interval. So if you'll notice, the alpha level corresponds to the confidence interval that will sum the two numbers up to be 100%. And the picture hopefully will show you why.